Current, resistance and voltage. Have you ever wondered how your phone charges when you plug it into a socket? When a charger is plugged in, negatively charged particles called electrons, which are already present inside the wires, start moving in the same net direction. This flow of electrons is what we call electric current. The voltage, or electrical pressure, pushes these electrons along the wires. Free electrons move along a zigzag path, colliding with each other and with fixed atoms within the material, creating resistance. This resistance makes the wire and any connected devices, like your phone charger, heat up. Today, you'll be able to define current, voltage and resistance, explain the relationship of current and charge, calculate for current, explain the relationship between current, voltage and resistance through Ohm's law. Use Ohm's law to calculate for current, voltage or resistance. Current, measured in amps or amperes, A, is the rate of flow of charge in a circuit. This flow is in the form of electrons flowing through a circuit. An ammeter is used to measure current. It is always connected in series with the circuit. Calculating current. Electric current is the amount of charge passing through a component per second. This relationship between current, charge, and time is expressed by the equation current, I, equals charge, Q, divide by time, T. Example, calculate the current in an air conditioning unit that has a charge of 18,400 C flowing through it every hour. Step 1. What are the given and missing values? Step 2. Which formula will we be using? Step 3. Substitute the values. Step 4. Solve. Try this. A current of 4.8 A flows through a circuit for 45 seconds. How much electric charge passes through the circuit during this time? Voltage, measured in volts. V, is the pressure or push behind the flow of current. It is also referred to as potential difference. A voltmeter is used to measure voltage. It is placed parallel to the component, S, to measure the voltage in a circuit. Resistance, measured in ohms, Greek letter omega, is a measure of how much a material opposes the flow of electric current going through it. The greater the resistance, the more energy is needed to push the current through the component, which can affect the overall performance of electrical circuits. An ohmmeter is used to measure the amount of resistance present when a current is passed through a particular component. Ohm's law. Ohm's law states that the current through a conductor is directly proportional to the potential difference across it, provided the temperature remains constant. Example, calculate the voltage, or potential difference, through a resistor with a resistance of 40 Greek letter omega with a current of 0.6 A flowing through it. Step 1. What are the given and missing values? Step 2. Which formula will we be using? Step 3. Substitute the values. Step 4. Solve. Try this. If the current is increased from 0.6 A to 2.2 A while maintaining the same voltage of 24 V, what will be the new resistance required? Summary. Current is the rate of flow of charge in a circuit. This flow is in the form of electrons flowing through a circuit. Current is measured in amperes, A, using an ammeter. Voltage is the pressure or push behind the flow of current. It is measured in volts, V, using a voltmeter. Voltage is also referred to as potential difference. Resistance opposes current flow and is measured in ohms, Greek letter omega. It can be calculated by dividing the voltage by the current.